Most people have a very strange, almost mindless reaction when they see a line of ants marching across their bathroom tiles. It's an instinctive thing. They get annoyed. They reach for a can of poison, a spray bottle, or just a crumpled up wet paper towel. They see an infestation, a nuisance to be scrubbed away so they can get back to their morning routine. But they are missing it. They are missing a spectacular display of biological computation happening right next to their toothbrush. You see, I've always been bothered by people who just accept names as answers. Biologists will look at that line of ants and tell you, oh, that's simple, Feynman. Ants use pheromones to find food. But wait, think about that. That's not an answer. That's just repeating a word. Pheromone is just a label for a chemical. Calling it a name doesn't explain the intelligence. It doesn't explain the how. It doesn't explain how a creature with a brain smaller than a grain of sand, a tiny blob containing maybe 250,000 neurons, which is nothing compared to your 86 billion, can solve a complex geometric optimization problem that would make a modern civil engineer sweat. I remember sitting on my bathroom floor for hours. I wasn't doing anything productive by the world's standards. I was just watching a lone scout ant. I didn't just look at it. I began to measure it. This is the key to physics. You don't just observe, you quantify. I took out my watch and I timed this little guy. It was wandering in what looked like a completely drunken, aimless stumble. It would go 3 inches to the left, then stop, jiggle its antennae, turn 180 degrees, and go back 2 inches. Then it would perform a little loop-de-loop, wander toward the bathtub, and then head back toward the baseboard. It took that scout exactly 22 minutes and 14 seconds to travel just 6 feet from the wall to the edge of the sink. 22 minutes! Think about the scale of that. If you or I took that long, proportionally, to find our own kitchen in the morning, we would have starved to death 10,000 years ago. To the casual observer, that ant looked stupid. It looked lost. It looked like a glitch in nature. But I knew better. I've learned from years of staring at atoms and equations that nature doesn't do aimless without a very good reason. Nature is never wasteful. She's just subtle. So I decided to play a game. I decided to challenge the ant. I placed a small, single crystal of sugar, just one on the far side of the tile, about 4 feet away from their nest entrance. I wanted to see the transformation from stupid scout to optimal highway. I watched that first scout stumble onto the sugar. Now here is the first point of interest. The ant doesn't just eat the sugar and stay there. It grabs a microscopic grain and it immediately turns around. But it doesn't take 22 minutes to get home. I timed it again. It took 8 minutes and 45 seconds. Wait. Think about that. It's already nearly 3 times faster. It hasn't found the perfect straight line yet, but it's already smoothing the curve. As it travels back, it's pressing its abdomen to the tile, laying down that invisible chemical trail, the pheromone. Now, most people think this is like a person leaving breadcrumbs, but it's much more sophisticated than breadcrumbs. It's a dynamic, evaporating data stream. I sat there, watching the clock. 10 minutes passed, then 15. Suddenly, there wasn't just one ant. There were 5, then 12, then 50. Within a half hour, there was a thick black line, a living rope of ants moving with terrifying mechanical efficiency. I picked a random ant in the middle of this new highway, and I started my stopwatch. It didn't take 20 minutes. It didn't take 8 minutes. It traveled the entire distance in exactly 41 seconds. Do the math with me. From 22 minutes down to 41 seconds. That is a 200% increase in efficiency. And it happened in less time than it takes to watch a sitcom on television. No meetings were held in the nest. No general drew a map on the wall. No central command center gave an order via radio. This wasn't just insects finding food. This was an avalanche of discovery. It was a physical system much like a star forming from a cloud of gas or a crystal growing in a solution, calculating the shortest distance between 2 points using nothing but the rate of chemical evaporation and the speed of a tiny leg's stride. This is the first layer of the mystery. The intelligence isn't inside the ant. The ant is just a simple machine. The intelligence is in the relationship between the ants, the sugar, and the floor. It's a distributed calculation. And if you don't understand the brutal logic of that first jiggle, the random drunken walk of that scout, you will never understand how the universe actually organizes itself from the bottom up. Everything you think you know about leadership and planning is about to be turned upside down by a bunch of pests in a bathroom. So, we have this perfect highway, a black line of ants, moving like a conveyor belt, 41 seconds from point A to point B. If you're an engineer, you look at that and you say, success, we have reached the peak of efficiency. You'd be tempted to lock it in, to pave over that trail and make it permanent. But this is where the logic of the universe takes a very strange, very counterintuitive turn. I kept watching. I didn't get up. I wanted to see if the perfect system had any flaws. And I noticed something that most people would dismiss as a failure of biology. Every once in a while, an ant would come marching down that high-strength, high-scent pheromone highway, and for no apparent reason, it would just leave. It would wander off the path. It would ignore the collective wisdom of its thousand sisters and head out into the barren porcelain desert toward the bathtub or the towel rack. I call these the stragglers. At first, I thought they were just broken ants. Maybe their antennae were clogged with dust, or maybe they had a genetic glitch that messed up their chemical sensors. In any human system in a factory or a military unit, these stragglers would be court-martialed or fired. They were inefficient. They were wasting energy. They were an error in the code. But wait, think about that. Suppose I have a colony of perfect ants. Ants that follow the trail with 100% accuracy. No questions asked. Everything is great as long as the sugar stays in the same place. But what happens if I move the sugar? What if I slide that crystal 2 inches to the left? Those perfect ants would keep marching to the empty spot where the sugar used to be. They would follow that old ghost trail until they all collapsed from exhaustion and died of hunger just inches away from a new meal. They would be prisoners of their own efficiency. They would have zero error, but they would also have zero intelligence. They would be incapable of learning that the world has changed. This is the mind break. I realized that the straggler, the broken ant, is actually the most important part of the colony. The straggler is the search engine. It is the randomizer that allows the system to remain flexible. I decided to test this with a new experiment. I placed a tiny crumb of sugar nearby, which they found immediately. Then I placed a giant, massive pile of sugar much further away, hidden behind the base of the toilet. At first, the colony ignored the giant pile. They exploited the small crumb. Why wouldn't they? The trail was strong. But because about 5% of those ants were bad at following the trail because they were jiggling off into the unknown, one of them eventually stumbled onto the giant pile. And because the giant pile offered a much bigger reward, that ant headed back to the nest, laying a much heavier pheromone trail than the ones returning from the tiny crumb. Slowly, like a shifting tide, the main highway began to dissolve from the small crumb and reorganize itself toward the giant pile. It was a beautiful thing to see. The colony learned through a process of collective forgetting and rediscovery. But it didn't learn through a brain. It learned through statistics. This brings us to a fundamental constant of the bathroom floor, the evaporation rate. Think about this carefully. If the pheromones never evaporated, if they stayed on the tile forever like a permanent ink, the ants would be stuck forever on the first path they ever found. They could never unlearn. But if the pheromones evaporated too fast, the trail would disappear before the next ant could find it, and the highway would never form. The evaporation rate is the clock speed of the system. It's the refresh rate of reality. It's a physical parameter that determines how long the colony remembers a piece of information. In physics, we call this the leaky integrator model. You have to forget the old bad information to make room for the new better information. Wait. Think about what that means for us, for our schools, our corporations, our lives. We are so obsessed with efficiency. We try to eliminate the stragglers. We try to make everyone follow the high pheromone highway of best practices. We try to make information permanent. But by doing that, we are stripping away our ability to adapt. We are building systems that are brittle. The ants taught me that the error isn't a glitch. The error is the mechanism of discovery. If you don't have the jiggle, the random, stupid walk into the dark, you are doomed to stay stuck at a local optimum while the rest of the universe moves on without you. We've moved from simple geometry to the deep, messy world of stochastic optimization. We've discovered that to be truly smart, you have to allow yourself to be a little bit stupid. But how does this work at the deepest level of the atoms themselves? How does a pile of chemicals on a floor connect to the way light travels or the way an electron finds its path? To see the why behind the ant's highway, we have to look at the third layer of reality, the principle of least action. Now we're going to peel back the final layer of this onion. We've seen the ants jiggling on the bathroom floor, and we've understood why they need those stragglers to avoid the trap of perfect efficiency. But now we have to ask the big one, the why that connects a 6-foot tile floor to the very architecture of the stars. Why does a mess of uncoordinated chemical leaking insects converge on a solution that looks like it was drafted by a master geometer? To understand that, you have to look at the principle of least action. In physics, this is the holy grail. Whether it's a ball flying through the air, a planet orbiting a sun, or a ray of light bending through a glass of water, nature always chooses the path where a certain quantity, the action is at a minimum. Most people ask, how does the ray of light know which path is the fastest before it even starts moving? It doesn't have eyes. It doesn't have a stopwatch. This is the secret I spent my life trying to crack with quantum electrodynamics. The light doesn't know. The light doesn't choose. Instead, the light takes every possible path at once. It's an infinite number of scout ants exploring the entire universe simultaneously. It goes to the destination in a straight line, but it also goes by way of Mars, and by way of the corner of the room, and by way of the ceiling. But here is the mathematical miracle. The paths that are long and winding cancel each other out. Their phases don't line up. They interfere destructively. Only the path of least action, the shortest, most efficient route, has all its jiggles in sync. The straight line isn't a decision made by the light, it's the summation of all possible paths. The ants in my bathroom are a macroscopic, living version of a quantum particle. Each individual ant is a path. The pheromone trail is the probability amplitude. The reinforcement of the trail is what we call constructive interference. When I sat there on the floor, I wasn't just looking at biology. I was looking at the path integral of life. I realized that the mind of the colony isn't located inside the ants' heads. The ants' brains are too small for that kind of math. The mind is the bathroom floor itself. It is a distributed computer where the memory is written in evaporating chemicals and the processing is done by the physical movement of 1,000 pairs of legs. Think about the scale of this. If I have 1,000 ants and each ant makes a choice every time it hits a tile boundary, the number of possible paths across that floor is larger than the number of atoms in the observable universe. And yet, within 30 minutes, they have filtered through that near infinite noise and found the one signal that works. This is the third layer of reality. We used to think that to solve a big problem, you needed a big brain, a central processor like a king or a CEO. But the universe shows us that intelligence is a field. It's a property of the jiggling. Whether it's an electron finding its way through a crystal lattice or a scout ant finding its way to a sugar cube, the law is the same. Total exploration leads to optimal action. If you understand this, you stop looking at the world as a collection of things and start looking at it as a series of calculations. The bathroom floor isn't just a floor. It's a biological supercomputer. And the math it's doing right there next to your bathtub is the exact same math that keeps the planets in their orbits and the electrons in their shells. But there's one more step in the avalanche. How does this ant logic change the way we build our world? And what does it mean for you, a human being, trying to find your own path in a world full of noise? You might think this is just a charming story about a physicist with too much free time. But the ant logic I saw on those tiles has triggered a literal avalanche in the world of modern technology. We've stopped trying to be smarter than the ants and started trying to mimic them. We call it ant colony optimization, ACO. When you open an app on your phone to find the fastest route through a city with 1 million shifting cars and traffic jams, you aren't using a master map that knows everything. You are using digital pheromones. Thousands of digital scouts are jiggling through the virtual streets of your city, reinforcing the paths that move the fastest. When an internet router sends your data across the ocean, it's not using a fixed plan. It's using ant logic to bypass congestion in real time. We have built the most advanced civilization in history by mimicking the stupidity of insects. But there's a deeper, more philosophical proof here. It's the lesson of the straggler. I've spent my life in science being a straggler. When the high pheromone highway of classical physics said that electrons should behave like tiny predictable billiard balls, a few of us decided to wander off into the messy world of quantum waves. We looked like we were failing. We looked like we were lost in the corner of the bathtub. But that's where the sugar was. That's where the new laws of the universe were hidden. Most people are terrified of being wrong. They are terrified of leaving the path. They want the correct answer and they want it now. But the truth is not a fixed thing you find in a book. The truth is a process. It's the result of an infinite amount of jiggling, exploring, failing, and forgetting until only the most efficient path remains. The avalanche that started with me watching a scout ant in a wash basin 40 years ago is still going on. It's leading us to biocomputing, where we stop trying to force machines to be perfectly logical and start letting them be chaotic so they can solve problems we haven't even conceived of yet. The great chessboard of nature is everywhere, under your sink, in your garden, in the way your own neurons fire. The pieces are moving, the pheromones are evaporating, and the universe is constantly calculating its next move. The speed of light, the gravity of the moon, the heat of a rubber band, and the path of an ant, they are all connected by the same beautiful, brutal logic of least action. The universe is constantly trying to find the shortest way home. And the fact that we can sit on a bathroom floor and actually understand it, that we can use a crystal of sugar to unlock the secrets of the cosmos, that's the beauty of physics. Not comfort, not simplicity. Truth clears throat. So, the next time you see an ant in your sink, don't reach for the paper towel. Take out your watch. Observe the jiggle. Because you aren't looking at a pest. You're looking at the fundamental machinery of reality, doing its math, one tiny leg at a time.